So, we talked last time, we worked through this example, and we talked about that the future value and the present value will have opposite signs. Do you remember why that is? Yeah, it's a sign convention of the TIBA2 plus. Cash flows in opposite directions have opposite signs. If you are trying to calculate the rate or the number of periods and you put both of those in as positive or both of them in as negative, what error will you get? 5 or S, depending on how you want to think about it. Okay, now let's talk about the concept of discounting. We know that a cash flow is worth more today than it would be a year from now. So I'm only going to be willing to purchase that cash flow at a discount. And so we talk about this concept of taking the present value of things. We also refer to that as discounting. And we refer to the required rate of return as the discount rate. So don't let that terminology freak you out. Now, when I'm thinking about making an investment, I am indifferent between getting the present value today or getting those future values out in the future. In other words, they are equally attractive to me. And so if I can buy something for less than the present value of the future cash flows, that's a good deal, and it increases my wealth. If I pay more than the present value of the future cash flows, that's a bad deal. So by the way, we're going to mention that the price or value of anything is the sum of the present values of the future cash flows discounted at a rate appropriate to the risk. That's the price of anything, is that present value of the future cash flows. Okay, so we're offered an investment today that will pay 121 2 years from today. Your required rate of return is 10%. What's it worth to you today? Now, as we mentioned last time, you can do this with the equations, but it's so much faster, especially when it gets more complex, to use the calculator. So here we go. What's the first thing we do with our calculator when we're going to work a time value of money problem? Second? Yeah, FV. And what does it say about FV? Clear TVM. We're clearing out its brain. Now, they're telling us we're going to get 121 2 years from today. What's that? Is that a present value or future value? Future value. And what am I going to do with 2? What button should I hit next? And, very good. And what should I do with the 10%? I per Y. And then what should I compute? Yeah, compute the present value. And notice that the sign is negative. That's just the sign convention on the TIBA2 plus. Thus, I am indifferent between receiving $100 today or $121 2 years from today. If I offered you this for $95, would you take the deal? Yeah, and you'd be improving your wealth by $5. What if I offered to sell you this deal for $105? No, you'd tell me to pound salt, right? That's not going to happen. Okay, let's see what else we've got here. So, we could manipulate the formula to find the interest rate. And here's how we would do that. First of all, we would take our future value formula, we would divide both sides by the present value, and then we would take everything to the 1 over t power, which is getting a little hairy, and then we would have to subtract 1, and that gives us r. By the way, there's a whole lot easier way to do that. It's called the TIBA2 plus. So, here we go. Get your calculator up. What's the first thing we do? Second, clear TVM. An investment of $100 provides a single payment of $133.10 3 years from now. What is the annual interest rate? By the way, if I say the interest rate is 7%, it's always on an annual basis. Even if I say 7% compounded quarterly, that 7% is still an annual number. So be very careful. I would have to say 7% per quarter for it to be a quarterly rate. Okay, so what are we going to do with $133.10? 133.1. What are we going to do with that? Future value. And what will I do with 100? Present value, but what do I have to do first? Yeah, you got to make it negative or it's not going to work. So negative present value. What would I do with 3? What button do I hit next? N, very good. And then what do I compute? Compute I per Y, and that gives me 10%. By the way, this little star up here, that tells you that that is an answer that the calculator has computed on its own. That's not something you entered, it's something the calculator computed. Now, if you want to see what you put in, all you have to do is say recall N, and you can see that, recall present value, recall future value, and then, by the way, just to make sure we got it all cleared out, you could say recall payment, and it should be 0. Questions? By the way, am I proving to any of you that you're a bit rusty on the calculator? Yeah, good. Okay, now oh my goodness, this is the most painful one. And it's the same down to where we've taken it to the 1 over t power, but then we have to get that t out of that, we got to get that t out of there. So what do? Well, now we have to take the natural log. Do you see how the formulas start to get very hairy in a hurry? If you're not into natural logs, which I'm not, then there's a better way to do this. It's called the TIBA2+. So here we go. If you invest $1,000 today, at some point in the future, you will receive $1,402.55. Your investment earns 7%. 7% per what? Year, right? Because I didn't tell you it must be year. How many years does the investment last? So we're going to get our calculator up here. We're going to clear, and then what are we going to do? Second, clear TVM. I've got 1402.55. What do I do with that? Future value. And I got 1,000. What have I got to do with that? Got to make it negative, and then present value. What do I do with 7? 7, I per Y, and then what do I compute? N. So 4.9999998. What do you think that's going to be on a multiple choice question? 5, right? It's going to be 5. So that's how we do it. By the way, was that easier than whipping out your natural log? Oh, it's a whole lot easier, right? Oh my goodness, this TIBA2+, I wish I had known about it way earlier. Okay, now we're going to talk about compounding within a period. Compounding is just the earning of interest on interest. If you're getting simple interest, all you do is you collect the interest on the initial principal. So for example, if you've got $100 on deposit at 5%, after 1 year, you receive $5. After another year, you receive another $5, and it just keeps going on like that. But notice we are not receiving any interest on the interest. If you did compounding at the end of the first year, you would have $105. And then over the next year, you would receive 5% of $105, which is $5.25. So now you would have $110.25 versus the $110 that you would have under simple interest. And if you don't remember that, you need to go back and do some reviewing. Now let's talk about how you're going to see these things. First of all, 12% compounded monthly. I just mentioned that everything is annual unless it's said per so much, right? If per month, per quarter, then it's something else. But if I don't say that, it's annual. Annual compounded monthly. What does that really mean? Well, it means we're going to take the 12% divided by the number of months in a year. By the way, how many months are in a year? 12. So 12% divided by 12 gives us 1% per month. And so what's really going to happen is if I put $100 in the bank on January 1st, on February 1st, I am now going to have $101. And then I'm going to earn 1% interest on that $101 over the month of February, right? And at the end of February, now I'm going to have more than $102 because I will also have earned, in fact, I'll have $102.01, right? And so that's the way compounding works. By the way, compound interest for the same interest rate will always give you a greater return because you're earning interest on interest. So if you are loaning money, you want compound interest. If you are borrowing money, what would you prefer? Simple interest. You'd prefer simple interest. So when I was 17, my mom loaned me some money to buy a car. And she was always trying to teach me new things, and she had me sit down and figure out the repayment schedule. And she had already told me what the interest rate was going to be. And so I figured it out, and she said, "Oh no." She said, "You're using simple interest. I charge compound interest." She's a former math teacher. She knows these things, right? Okay. So that means that we are actually going to be earning more than 12% per year with 12% compounded monthly. And the actual amount that we earn is going to be called the effective annual rate. The effective annual rate takes compounding into account. We call it the effective rate, the effective annual rate. It takes compounding into account.
So is this how you find out, say, what your monthly note would be, say if you bought a car?
Oh yeah. Oh, we will get to that today.
Good, because I couldn't figure that out.
Oh, well.
I couldn't figure out how you came out with that 5%.
Okay, well, I will very much teach. If you let me keep going, we'll get there. Okay. Now, by the way, the next one down says 7% compounded quarterly. How many quarters are in a year? 4. How many months are in a quarter? 3. Very good. So, if I wanted to figure out the quarterly interest rate, what would I do with that 7%? Divide by 4. Very good. Divide by 4 gives me my quarterly interest rate. And then we have 6% compounded semi-annually. What does semi-annual mean? Twice per year. Usually ladies get this, guys don't. Does anyone know why? This is going to sound totally sexist, but it happens in my house, right? Are there certain places that have semi-annual sales? Oh, you guys didn't know that? Oh my goodness. Yeah, so the semi-annual sale, that's my wife knows very much that semi-annual means every 6 months, right? Okay, so semi-annual is twice per year. So if I were going to figure out the interest rate over a 6-month period, what would I do with that 6%? Divide by 2, so it's 3% every 6 months. Now, all of these are on an annual basis, and we have a name for these numbers, 12, 7, and 6. We call them stated interest rates. We call them quoted interest rates. We call them nominal interest rates, and we call them annual percentage rate, APR. Have you guys ever heard of APR? You see the ads on TV, they say, ooh, 7% APR for well-qualified borrowers, right? Which means probably not you. Okay, so annual percentage rate, APR, those are all the number of periods in the year times the sub-period rate. In our first example, the sub-period rate was 1% per month multiplied by 12 months in the year. And so those are stated nominal, quoted, or annual percentage rate. Now we need to get to, though, this effective annual rate. And here is the way I want you to think of the effective annual rate. It is the interest rate that, if compounded once per year, gives you the same amount of money at the end of the year as our 12% compounded monthly or 7% compounded quarterly. And so basically, it's taking all that compounding within the year and putting it into an annual number. Okay, so how are we going to find that effective annual rate? Well, of course, there's a formula, and feel free to use the formula if you want. M is the number of compoundings per year. R is the nominal rate. And so R per M would be the sub-period rate. And you could do that formula, and you know, more power to you if you can remember that. But I'm going to show you an easier way. Would you like to know an easier way? Oh, me too. Okay, so get your calculator up here. And I want you to hit clear. And I want you to hit the second button, but this time I want you to hit the number 2. The number 2. Does your calculator now say NOM, N-O-M? Yeah, what do you think NOM stands for? Nominal. And so this is going to be one of those nominal, stated, quoted, or annual percentage rates. All 4 of those are the same, and they all would just very pleasantly fit into this spot. So if we've got 12% compounded monthly, I'm going to put in 12, enter. By the way, notice I didn't put it in as a decimal, I put it in as a percentage. Put it in as a percentage, so 12, enter. By the way, you've got to hit enter because otherwise it will forget. If you don't hit enter, it will forget. Now, how do I know that it got my entry? You see that little weird triangle thing? That lets me know that it got my entry. And then I'm going to arrow up, strangely. I'm going to arrow up, and I've got C per Y. What do you think C per Y stands for? Compoundings per year. Compoundings per year. How many compoundings per year are there in monthly compounding? 12. Now I want you to see something here. If I type in 12, if I don't hit enter, do you see the little triangle? No. So I hit enter, and boom, there it is. You see that? Okay. Now I'm going to arrow up, and it says EFF. What do you think EFF stands for? What did we say we were trying to find? Yeah, it's the effective annual rate. So EFF is the same as EAR. EFF is the same as EAR. Now you're looking at this, and it says the effective rate is 0. Is that true?
Yeah.
No. What have you got to hit? What button? You got to hit compute, right? And if you're just on an exam and you're blanking out, look up at the top of the screen, and it's going to give you some hints. It's going to say, hey, bro, you could do compute, you can do enter, you can do arrow up, or you can do arrow down. What do you want to do? We want to compute. By the way, there it is, 12.68250301. It's exactly the same number that we would have gotten if we had done the formula. But once you get used to doing this, you will be so much faster doing it this way. By the way, this is the most common thing that students forget how to do on their calculator for the exam. And they come to my office afterward to look at their exam, and I show it to them, and they're like, oh, damn, I remember that now. Why do you think I tell you that? I want you to already have that sting so that you will remember how to do this. Okay. Any questions on that?
How do we reset, like clear that work?
Okay, that's a good question. So we could hit clear, and we can hit second and clear work. Second clear work. But here's the issue. When you do that, second number 2, so second clear work. You see that you cleared it out. But check this out. Arrow up. Boom. There it is again. Why did it stay in there? The answer is, what if you're a mortgage lender or you're a finance person at a car lot? You will always have this as 12, right? Does that make sense? It will always be 12. And so the calculator is doing you a favor by leaving it in there. As a finance student, are we necessarily doing you a favor by leaving it in there? No, so you should always check this. By the way, if I said there was weekly compounding, how many weeks are there in a year? 52. Surprisingly, the most common wrong answer to that question is 54. I don't know why. Okay, so we got 52 one-week periods. What if we have 2-week periods in the year? How many of those do we have in a year? 26. And so to find the nominal rate, I would take that 2-week interest rate and multiply by 26. My C per Y would be 26. And I would compute the effective annual rate. And that problem is actually on the exam practice, and it's going to blow your mind how huge the effective annual rate can be for what seems like an only slightly high 2-week rate. By the way, this is how those check cashing places make their money, right? Payday loans. Because oh, they're only charging me 6% for the loan. Well, it's 6% over 2 weeks. Let's find out how much that would be. So we're going to go down. we're going to say 6%, and it's for 2 weeks. So I'm going to multiply by 26 2-week periods in a year. That makes my nominal rate 156%. That sounds like highway robbery. I'm going to hit enter, or what should I put in for C per Y?
26.
Yeah, 26. 26, enter, arrow up, and I'm going to compute. Oh, crap, look at that, 355%. Are they doing you any favors? No. You'd be better off putting that on a credit card. By the way, what kind of interest does a credit card charge?
About 30.
Yeah, well, it's compound, right?
Yeah.
And so if you don't pay all your bill this month, now you've got interest and remaining principal there, and you're going to have to pay interest on both of those things going forward, and it can quickly snowball. And you're right, it's somewhere between 18 and 30 depending on your credit. It's kind of crazy to put stuff on a credit card. It's even crazier to do a payday loan. What kind of people do you think are getting payday loans? Do you think they can get a credit card? No. Why do you think they can't get a credit card?
Bad credit.
They got bad credit, right? Does that make sense? By the way, who should you charge a higher interest rate to? Rich people or poor people? Yeah, why do we charge a higher interest rate to the poor? Yeah, it's really just risk. I don't care. I don't care if you're poor or rich. Here's what I care. Are you able to repay the loan? Who is most able to repay the loan? The rich person. Who is most likely to default? The poor person. Does that make sense? I'm so glad to hear that we don't have people in here that are confused and think we should just offer stuff for free to people who are not going to pay us back. Now, let's talk about...
It's free.
What's that?
It's free.
Yeah. Folks, there's no such thing as a free lunch. If you get your student debt forgiven, who's actually paying? Taxpayers. So you and your high school buddy decided to go out and become a plumber because he didn't want to take on student loans, right? Now your high school buddy's out there making good money, and if you default on your student loans, who ends up, or get forgiven your student loans, who ends up paying for it? Your buddy, right? Okay. Compounding within the period. So something to keep in mind here is the more frequently we compound, the higher the effective annual rate is for the same stated quoted annual percentage rate or nominal rate. And so we can see if we compound 12 APR at once per year, that's just 12% effective annual rate. And so the effective annual rate and the APR will always be the same if there's only one compounding per year. But what if there's two? Well, the interest rate goes up to 12.36%. So we've gone up from 12 to 12.36. But what if we double the compounding again? It goes up to 12.55%. I don't know what's wrong with this thing that it's only showing part of the slide, isn't it? What the hell? Come on. There we go. Okay, and so if we do it, if we double it, we go from 12.36 to 12.55. That's only a 0.19% increase. The first time we doubled, we had a 0.36% increase. Let's double it again. We're going to take it on up to 8. And we notice we go from 12.55 to 12.65. It's still going up, but it's going up at a lower rate. And so it's always increasing, but it's increasing at a decreasing rate. And eventually, basically, this thing is going to become what we call asymptotal. You don't have to know that word, but here's what it means. We'll call it C per Y. And this is EAR. And this is with one compounding per year. And we get out here, and basically, it gets close to this line, but it never actually touches it. It's like an airplane landing on a field, and every meter it goes forward, it drops an additional half of the distance to the runway. If you always are dropping by half the distance to the runway, will you ever get to the runway? Not going to happen. And so that's the way this works. It's going to get up to this situation, and it's not going to get any higher. And so we could actually, there's going to be a maximum to this, and it's going to be what we call continuous compounding. Continuous compounding is where we compound an infinite number of times per year. And there's going to be a formula for this that involves the exponential. And you say, what's the exponential? Oh, well, easy. It's just the inverse of the natural log. We've already said we don't want to mess with that, but it turns out that you can actually get your calculator to do this work for you. You can actually trick your calculator into it, and I'll explain to you why it's possible here in a second. We're going to hit clear, and then we're going to hit second, and the number 2. We're looking at 12% APR, and we are compounding it an infinite number of times per year. So the closest number I can get to infinity in my calculator is if I hit a bunch of 9s. 9, 9, 9, 9, 9, 9, 9, 9, 9. And I fill it up as much as I can with 9s, and then I hit enter. Now I'm going to arrow up, and then I'm going to compute. If we do continuous compounding, this is going to be our interest rate. I could actually prove to you by working it through with the formula and then subtracting the two numbers. They will be the same. And here's why. Remember that as we go further and further out, that the distance, that this increase gets very, 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 very small. And so the difference between 9 and infinity is infinitesimally small. So if I were you, what would I do? Would I write down the formula and try to remember how to do the exponential on my calculator? Or would I fool my calculator into thinking infinity by throwing a bunch of 9s into it? What do you think? I'm going to go with option 2, right? Questions?
I have a question.
Yeah.
I was trying to do the practice homework, and they were giving us the EAR and to find the APR.
Oh, sweet. Let's go through that. Thank you for bringing that up. So I'm going to hit second clear work. And I'm going to go up here, and let's say the effective annual rate is 12.36. I'm going to hit enter. I'm going to arrow down. And we are compounding twice per year. So I'm going to hit 2, enter, and I'm going to arrow down. What do you think I'm going to do here? Compute. That gives us 12%, as we mentioned earlier. 12.36 compounded semi-annually, or 12 compounded semi-annually is 12.36. So we can go from nominal to effective. We can go from effective to nominal. You're saying, wait a minute, could I put in both nominal and effective and compute the compoundings per year? No. For some reason, the calculator will not let you do that. Why? I don't know. People in
the book, in the formula, it says that the E is a constant.
It is.
So it's
2.71, yeah.
I mean, and I worked a couple things with that, and it came out fine, and worked a couple other things, and it didn't come out fine. So that is a constant, you can use that in the formula.
Oh, yeah. In fact, since you obviously seem to be quite interested in it, we'll go ahead and do it here. So the R here is going to be in decimal form. Anytime we use something in a formula, we got to put it in decimal form. So I'm going to put in 0.12, and then I'm going to hit second, and I'm going to hit LN. Do you see what is above LN? Yeah, it's e to the x. So there we go. 1.12. Do you see that? Now I got to subtract 1, and that gives me the decimal, and I'm multiplied by 100. And it should give me exactly what I got earlier. Feel free if you want to play that game, but I think I've shown you an easier way. Questions? Hey folks, do I care how you get the answer? No. As long as you get the right answer and you didn't cheat, I'm all good. Now, afterwards, when you come to me and you say, I didn't have enough time, and I'll say, did you use the formulas? And you'll say, yes. And I'll say, that's why. Okay, questions? Okay, now we're going to move on to the special cash flow streams. So we got another one here. Okay, so far everything we've been talking about are called lump sums. I invest a lump of money here, and then down in the future I get a lump of money in return. Those are called lump sums, but seldom in the world of finance do things work that way. When you borrow money to buy a car or a house, you receive a lump sum to buy the car or the house, but then how do you pay it back? Payments, right? So we've got this stream of cash flows. And so we have different styles of these cash flows, and we can talk about different names for them. So the first one I want to talk to you about is the perpetuity. What does perpetual mean? Yeah, it goes on forever. And so a perpetuity is just a stream of cash flows, identical cash flows that just goes on forever. And we can easily find the present value by just taking the amount of that cash flow and dividing by the rate. Now, note, the cash flow and the rate must be in the same time scale. So if we're talking about a monthly payment, that rate needs to be on a monthly basis. If we're talking about an annual payment, the rate needs to be on an annual basis. Now, to me, it's easier to use the formula in this situation. But if not, you can still use your calculator and fool it into thinking perpetuity by entering in 9999999 for the number of payments, and you will get the correct answer. But once again, I think this one's actually easier using the formula. Okay, so let's just work a really dirty example here. We're getting $100 a year. The required rate of return is 10%. What's the stream worth to you? So we want the present value. So we're going to take 100, divide by 0.1. Remember, if you're using it in a formula, the interest rate needs to be in decimal form. And there we go. It's worth $1,000. Now, how could I have fooled my calculator into doing this for me? Second, future value. Clear out your time value of money. What am I going to do with 100? Any ideas? PMT. What do you think PMT stands for? Payment. Very good. And we can put in a bunch of nines. What should I hit next? And that's like for an infinite number of payments. And required return is 10. What button should I hit next? I per Y. And then I can compute the present value. Bada bing, bada boom. It's exactly what we thought it would be, right? So even if you can't remember this formula, you can remember how to trick the calculator into giving you the answer. Questions? Okay, perpetuities, fairly rare. What we see more often are annuities. We'll get to them in a second. Now, what if you, instead of having a perpetuity, you have what's called a growing perpetuity? And that is a stream of cash flows that grows at the same rate throughout all eternity. And so it's going to grow 1% this year, 1% next year, and so forth. In fact, this would be I'm thinking about retirement now. Remember July 31st, 2037. I'm thinking about retirement, and I'm thinking about what kind of cash flows I want in retirement. A growing perpetuity would be good for me if I could get one that grew at the average rate of inflation. Does that make sense? Because that means I'm not going to start out eating steak and end up eating cat food, right? I'm just going to have, like really good hamburgers the whole time. Does that make sense? Because I'm going to have the same purchasing power throughout. So that's what I would like, is a growing perpetuity. Actually, do I want a perpetuity though? I don't plan to live forever, right? So those extra payments that would come in after that, they'd be going to whoever I leave my money to. I don't have any kids. My dogs will be gone by then, right? So I really wouldn't want that for myself. Okay, so how can I figure the value of this thing though? Well, it's the same as the perpetuity, only with a couple of adjustments. Number one, notice that it's C sub 1. C sub 1. The sub 1 means the cash flow at time 1. By the way, in finance, cash flows always happen at the end of the period. So C sub 1 happens at the end of the first year. Divide by R minus G. We know what R is. What do you think G is? That's the growth rate. And just like R, we have to use it in a decimal form. Just like R, we have to use it in a decimal form. An investment company offers you a stream of cash flows that grow at 5% per year. The first payment of $1,000 is due 1 year from today. Ding, ding, ding. We have C1, right? 1 year from today, that's C1. You require a return of 10% on this investment. How much is this investment worth to you today? So we could just take 1,000 and divide by the way, do you guys know how to use the parentheses on your calculator? Let's walk out through how to do that. So we're going to say 1,000. By the way, I would just do this math in my head, but I know most of you can't. So we're going to say divide by open parentheses 0.1 minus 0.05. What should I do next? Close parentheses and then equal. By the way, enter and equal are not the same thing. Sometimes they serve the same purpose, other times they do not. So always just use the one that you know will work and you'll be fine. Okay, so that's going to tell us $20,000. Now, how could I have fooled my calculator into giving me that same number? It's a little more difficult. First of all, I'm going to say second future value, clear up my time value of money. I'm going to put in C01 or C1 as 1,000 as my payment. And then for I per Y, I'm going to put in R minus G. What's 10 minus 5? 5, very good. 5, and then we're going to put that in for I per Y. And what would I put in for N for a growing perpetuity? Bunch of nines, right? And then I'm going to compute the present value. It gives me the same number. So there's usually more than two ways to do any problem in this class. Do I care how you do it as long as you don't cheat? No. Okay, we already talked about that. Now let's talk about annuities. How are annuities different than perpetuities? Well, an annuity only goes on for a certain amount of time. An annuity only goes on for a certain amount of time. In the traditional, very beginning way that we talk about annuities, it's for a set number of periods. But if you go out and buy something called an annuity from a life insurance company, it actually will pay you the same amount every month or year until you die. Do you think that the life insurance company might have a good idea of how long you're going to live on average? Yeah, they're in the business of making money by knowing when you're going to die, right? And so on the life insurance side, they're willing to provide coverage to you because they have a pretty good idea of when you're going to die, so they know how much they need to charge. On the other hand, if you are handing over a lump of money to them and saying, give me annual payments until I die, they have a pretty good idea of that. Now, here's a question for you. I have two 65-year-olds. One of them applies for life insurance. The other one applies for an annuity. Do you think that they have the same life expectancy? They're both 65. They're both, to all appearances, identical. One of them is applying for life insurance. One's applying for annuity. Which one do you expect to live longer? Yeah, the annuity person. This is called information asymmetry. Do you think I might know things about my family background, like the fact that my grandfather died at 50 from a stroke, right? And so at 65, I'm like, whoo, yeah, I'm going to buy life insurance. And they're like, yeah, he's probably not going to make it past 72. And then the other person that's out there buying an annuity, they think they're going to live longer, so they're going to get a better deal out of it. Does that make sense? And so if you look at the tables for those two things, the tables are different. They're not the same. Okay, Now, what kinds of annuities are we going to talk about? An ordinary annuity follows the timing of cash flow that we've already talked about, where the cash flows happen at the end of the period. An ordinary annuity, the cash flow happens at the end of the period. But for an annuity due, it happens at the beginning of the period. 95% of the annuities you run into are going to be ordinary annuities. 5% are going to be annuities due. So what kind of examples do we see of annuities? Well, we see car loans and mortgages. By the way, annuity makes it sound like it's always annual, but it could be any time period that you and the bank agree to. And so typically for car loans and mortgages, what time period are we looking at? Monthly, right? Okay. And then, of course, also your retirement. The formula is complex. If you're into formulas and you just love to do that sort of stuff, go out there to Google and look that up, right? I would highly advise against using the formula during an exam because it will A, take you too long, and B, you will get the wrong answer simply because you will do something wrong. So don't do that. Okay, so we're going to start with ordinary annuities, and we've already had this question today from Mr. Nylon. How can I figure a car payment? The first thing to know, when you borrow money, the amount that you are borrowing is the present value. And so if you're going to borrow $60,000 to buy a BMW, that's going to be your present value. And then we're going to do that for 5 years, and the interest rate is 6%. By the way, 6% per what? Year. And that is a stated, nominal, quoted, or annual percentage rate. How much are your monthly payments? By the way, your interest rate needs to be on the same time scale as, sorry about that, as the payments, right? And so if I've got a monthly payment, I've got to have monthly interest rate. So let's get our calculators out here. And what's the first thing we're going to do? Second, clear TBM. I was driving through a bank drive-through, and there was this young lady working there I'd had in class 5 years ago. And I was just depositing a little check. And she said, Dr. Haggard, do you remember me? And I said, yes, I do. And she said, I can still hear you in the back of my head saying, second, clear TBM. And I said, good, I've been successful. I want you to remember that all your life, right? Because otherwise you'll get messed up. By the way, she's working at a bank. Do you think it's important? Yeah. Okay, so 60,000, and I'm going to make this negative present value. By the way, I could have made it positive, and then the payment would have just come out negative. And then what am I going to put in for I per Y?
60 divided by 12.
Yeah, so I'm going to say 6 divided by 12, and here's the fun thing, you've got to hit equal. You've got to hit equal. That's going to give me 0.5. I'm going to say I per Y. What am I going to put in for N? Am I going to put in 5?
60.
No, we got to do 60. How did you get 60? Yeah, so it's 5 years times 12 months per year gives us 60 months. 60. And then what am I going to compute to find the payment? Compute PMT. Tells me it's $1,159.96 or 97 cents per month. Does that make sense? So, when you go to borrow money, what are you borrowing? Present value, future value? Present value. Okay, now we're going to figure out how much we borrowed. And by the way, this is a real life example. I bought my wife, this is in Halloween 2006, I bought my wife a 2007 Hyundai Santa Fe, and we were straight out of doctoral school, so I had no money. And so we had to borrow money to buy this car. And so I borrowed the money at 6.35% interest, and the payments were $526.39 per month, and it was a 5-year loan. By the way, 5 years was what it used to be the standard. What are they loaning money on cars now for? 7. I mean, it's getting crazy. If it's up to 8, it's even crazier, right? Okay, so how much did I borrow? Well, let's get our calculator out. What's the first thing we do? Second, clear TBM. 6.35. Can I hit I per Y, or what do I need to do here? Divide by 12, because that's an APR. Equal, and then I per Y. What do I put in for N? 60. 60, very good. 60 months, and then, let's see. Oh, I need to put in the amount that I'm looking for the amount that I'm borrowing. So I've already put in the payment, 526.39 payment, and then I'm going to compute the present value. And we see it was $26,999.95. In truth, I borrowed $27,000 to buy the vehicle, and so like my last payment would have been a few cents short, but I paid the car off early, so or I had to pay more, right? Okay, so that is how we find how much we borrowed, because remember, you always borrow the present value, so you compute the present value. Now we're going to find the interest rate. We borrowed $300,000 over 30 years. What do you think we bought with that $300,000? A house. Oh, by the way, let's talk about down. We say that if you are going to buy a house, you have to put 20% down. What does that mean? Yes, that's the amount of cash that you pay. So in this case, we've got $300,000. If that represents 80% of the value, all I have to do is say 300,000 divide by 0.8, and it tells me that the house was a $375,000 house. Does that make sense? So we would pay $75,000 up front, and we would borrow the remaining $300,000. So that's what we mean by a down payment. It's the money you put down toward the purchase price. You borrow the rest. Okay, so we've got $300,000. By the way, what's the amount that you borrow? It's the present value. So we're going to say 300,000, and I'm going to say negative present value. And we're doing it over 30 years. What's n? 360. That's 30 times 12. And then they tell us that the payment is $3,085.84 per month. I'm going to hit PMT. Notice that my present value is negative. My payment must be positive. What if my present value had been positive? What would I do with payment? Make it negative. You'll get exactly the same result. Okay, now we are finally ready to calculate I per Y. Looks like it's 1%. Does that mean we've borrowed money at 1%? No. What have we borrowed money at? Yeah, we got to multiply by 12. Remember, that's the sub-period rate. Because the payments are per month, this comes out as a monthly interest rate. In order to turn that into an APR, I need to multiply by the number of sub-periods in the year. For months, that's 12. So I'm going to multiply that by 12, and we get 12%. APR. Questions? Okay. Now we can find the loan term. You borrowed $100,000 at 10% interest. Your payments are $1,321.51 per month. What is the term of your loan in years? So here we go. What's the first thing we're going to do with the calculator? Second, future value, to clear that TVM. And we've got 1321.51. What should I do with that? Payment. And then we've got 100,000. What do I need to do with that? It's going to be present value, but what do I need to do with it? Got to make it negative because of the sign convention. I'm going to hit PV. I got 10% interest. That is an APR. What do I need to do? Divide by 12. And I'm going to put that in for I per Y. And then I think I'm ready to compute N. Does this mean 120 years? Months. It's 120 months. How am I going to convert that back to years? Divide by 12, because there are 12 months in a year. And there we go. It's actually 10 years. 10 years. Any questions on that? So when you get around to figuring rates or the number of periods, it is extremely extraordinarily crucial that you remember the sign convention for the TIBA2+. In fact, let's see what happens if we screw this up. 100,000 present value, compute N. Something really weird happens, and it doesn't even tell you there's an error. By the way, you should mentally know that this is a problem. Does anyone loan you money for negative 59 periods? No, that's jacked up. That's just not going to happen, right? Now, an annuity due is exactly the same as an annuity, except the payments happen at the beginning of the period instead of the end. If I offer you two identical sets of cash flows with the identical required return, and the only difference is that one of them gives you all the cash flows one period early, which one's going to be worth more? The one that gives you one period early or the other one? It's got to be the period early, right? Because we prefer money now to money later. And so an annuity due, all else equal, an annuity due will always have a higher present value. Okay, now on our calculator can handle this. And the way we're going to make this work is we are going to hit clear. We're going to say second PMT. What does that say above it? What does it say above the PMT button? It says BGN, which is short for begin. And when it comes up, it's going to be the current mode. And the current mode is the classic cash flows happening at the end of the period. That's what your calculator is set for right now if you've done the calculator purification ritual. Now, how could I get it to, instead of thinking at the end, to think at the beginning? Well, there's a clue. Look up at the top of the screen. What word do you see? Set. Now, look above the Enter key and see what you see. It says set. So how am I going to access that? I've got to hit second and enter. And boom, there it is. It says BGN. Now I want you to notice one other thing. Upper right-hand corner, what does it say? It says it has the BGN indicator, right? When you are getting wrong answers during an exam, the first thing I want you to check for is to see if that BGN indicator is up there. Because if you forget to reset your calculator after working one of these, all your other answers will be wrong. Let me say that one more time. If you forget to reset your calculator after working one of these, all your other answers will be wrong. And so when you start getting goofy answers that don't show up in the choices, check to make sure that BGN is turned off if you're not working an annuity due. Okay, now how would I get this to go back to the other way? What do you think?
Same stuff.
Yeah, same stuff, right? Second, enter. Changes it right back. And notice that BGN indicator went away. So let's see an example here. By the way, finance professors love this question because it actually forces you to do two calculations to get one answer. Ms. Wynn, you have a question? Okay. So you've got a crazy aunt who's given you the option of receiving $1,000 per year at the beginning of each year for 20 years or receiving the same payments at the end of each year. The interest rate is 5%. Which one is worth more? We already know which one's worth more. At the beginning of the year. More importantly, the question is how much more? Now, I want to start in BGN mode. I'm going to start in BGN mode. And I'm going to say second, enter. And it's going to change it to BGN. By the way, how did I get there? Second PMT, and then I did second enter to get it into BGN mode. Now I'm going to hit clear, and you can see that the BGN indicator is still there. Now I'm going to hit second, clear TBM. Now what should I do with 1,000? Payment, very good. Now what should I put in for N? 20. What should I put in for 5? So 5, and then what button? I for Y. And then what should I compute? Yeah, compute the present value. That's what it's going to be worth to you. So I'm getting negative $13,085 and some change. And here's what I'm going to do. I'm going to hit the minus key and hit store 1. By the way, your calculator has 10 memory locations, 0, 1 through 9, right? And I just put this in drawer, let's see, what did I do, store 1? Yeah, I just put it in drawer 1. Okay, now I'm going to hit clear. Now, you might think, wait a minute, I got to type all that in again. No, you don't, because everything else is exactly the same. All we need to do is say second PMT, second, enter. Notice it switched to end. The BGN indicator has gone away. And now all I have to do is compute present value. Now, here's the cool thing. This, first of all, we notice it's a smaller number as we predicted. The second thing is this thing already has a negative sign on it. In order to subtract it from the other thing we have, all I have to do now is say plus recall 1. Plus recall 1 equals. That tells me that the annuity due is worth $623.11 more than the ordinary annuity. We knew it would be worth more, we just didn't know how much. Now, if you run into this kind of problem on an exam, here's what I would tell you to do. Calculate the BGN thing first, because it will force you then to reset your calculator to END mode to calculate the ordinary annuity. And that way that BGN will not be hanging out up there giving you grief for the remainder of the exam. Questions?
You said clear it and then hit the minus and then store 1.
Yeah, so I came out with a negative present value. And so I just hit plus minus, and then I hit store 1.
Okay.
Yeah. And then to get it back, what do I hit? Recall 1. By the way, if I want to clear out all that, all I have to do is hit second memory, second clear work. But I really don't see any reason to ever do that, because anytime you say the new one, it overwrites the previous value. And it's not like the time value of money where it's going to be hanging out there just waiting to mess you up. It's not going to be a problem. Okay, now, not all the cash flows in this world are very nice and even. In fact, when you go out and make an investment in, say, a new factory, very often the cash flows are uneven. But it's not a problem. We can figure that out. And the way we're going to do it is by using the CF key on our calculator. And so we've got a series of cash flows here. We are investing $10,000 at time 0 in order to receive $2,500 at time 1, $2,500 at time 2, nothing at time 3, and $7,500 at time 4. And we're told that the required return is 7%. What we want to do is figure out what is the sum of the present value of all those cash flows. And there are two ways you can go about that. You can figure out the present value of each one of these things individually. Here's how I would do that. So minus 10,000 today, how much is that worth today? Minus 10,000, right? And then time 1 would be 2,500 divided by 1.07, or you could find the present value one period out using your calculator. 2,500 from period 2 is worth 2,500 divided by 1.07 squared, or you could use the calculator. And then for the 4th period, it would be 7,500 divided by 1.07 to the 4th power, or you could use the calculator with n equal 4. Any way you do it, you can add all those together and you'll get exactly the same number that we're going to get by doing it in a much easier way. Would you rather know a much easier way? I thought you might. So here we go. CF, second, clear work. Do you see the clear work is down here with a CE/C, so second, clear work. By the way, the reason we do that, if we had previously more cash flows than what we're going to put in this time, those other cash flows would be hanging out there just waiting to mess us up, right? So that's why we're going to clear it out. And so here we go. Cash flow at time 0, I'm going to put in 10,000, negative, enter. Arrow down, C01. What do you think I'm going to put in for C01? 2,500. By the way, if I don't hit enter, it's like it never even happened. I got to hit enter. And now I'm going to arrow down. Now we've got F01. F01 is the number of times in a row that that cash flow at time 1 shows up in a row. So how many times does this cash flow show up in a row? 2. So we're going to hit 2, we're going to hit enter. And we're going to arrow down. Now, notice it says C02. Don't let that freak you out. That doesn't mean cash flow at time 2. It means this is the second cash flow of, second new cash flow. And so the new cash flow this time is going to be 0. I need to hit enter, and then I can arrow down. What is F02? How many times in a row does that 0 cash flow happen? Just once, right? So I'm going to arrow down, and what am I going to put in for C03? 7,500. Enter. Now, I could arrow down, and we're just going to see that it's just 1, so it's always going to be 1 unless you change it. Now, how do I find the present value of those cash flows? Well, I can hit the NPV button. What does NPV stand for? Net present value. The net present value is simply the sum of the present values of all the cash flows where the negative cash flows are out and the positive cash flows are in, and that's exactly what we're looking for here. And all I've got to do is put in this rate. I'm going to put it in as a percentage, enter. Then I'm going to arrow down. What do you think I should do now? Yeah, compute. I'm getting $241.76. Let's see if that's, yep, okay. Now, sometimes people will say, wait a minute, couldn't I have done this? I could do, come on, I could put 2,500, and then I could just put F02 of 1, enter, arrow down. 2,500, enter, down, F02 is 1, and then C03 I could put in as 0, enter, and then I can put C04 in as 7,500, enter, and then I can hit NPV, arrow down, compute, and I get precisely the same answer. The answer is yes, you can. And for a problem like this, maybe that's fine. But what if I told you this? What if I told you that at time 1 through 17, we were going to receive $2,500, and then we would have 0, and then we would have 7,500 at the end. Do you really want to type all that in? No. It's better to learn how to use the calculator correctly. It's better to learn how to use the calculator correctly. How do you learn? Practice, practice, practice. How do you build speed? Any ideas? Practice, practice, practice. By the way, 3 types of loans. Number 1 is a pure discount loan. That is where I loan you $700 today with the promise that you're going to pay me back $100 a year from now. That's a pure discount loan. And then there are interest-only loans where I borrow $100 today and at 5%, and I just pay $5 every year until the term is up, and then I pay that final $5 of interest plus the $100 that I borrowed. So that's an interest-only loan. But the kind that we're most familiar with as consumers are amortized loans. And in an amortized loan, each payment represents a combination of interest and principal. And so you're paying down the loan balance as you go. In the beginning, because you owe more money, the interest is a bigger portion of that payment and the principal is a small part. But when you get close toward the end, the interest becomes smaller, smaller, smaller because you owe less, less, less. And so the amount that goes toward paying off your principal increases over the life of the loan. So how do we spot these patterns? Well, we come up with something called an amortization table. And the amortization table basically just breaks every payment down into interest and principal. And so what I could do is say, well, let's use an example here. We borrow $5,000 for 5 years at 9%. And so we're going to set up this kind of table here where we have our beginning balance, and we're going to figure out our total payment. I'm going to figure out the total payment using the time value money keys on my calculator. So I've got second clear TVM, clear, second clear TVM. I've got a 5-year loan, 5N, 9%, 9I per Y. I'm borrowing $5,000, boop, negative present value, and I'm going to compute the payment. So there you go. That's how we got that $1,285.46. That's the first step in creating an amortization table. After that, what we need to do is figure out how much interest we pay every year. In the beginning, how much money do I owe? I just borrowed $5,000. How much do I owe? $5,000. Now, how much interest is that going to earn or charge you over that first year? 9% of $5,000 is $450, right? And so what we know is that $1,285 and 54 cents or whatever is split between interest and principal. So if I take that $1,285 and subtract out the $450, everything that's left must be principal. And that's going to reduce my principal balance of the loan. How do I find out how much that I owe at the end of the year? I take the beginning balance, I subtract the principal paid, and that gives me my ending balance. Now, where do you think I get the beginning balance for the next year? It's the ending balance from the previous year, right? And so now I'm going to figure out how much interest I'm going to owe on that $4,164.54. I just multiply it by 0.09, and it gives me $374.81. And so I'm going to take my $1,285.46, subtract out the interest. That's going to give me the amount of principal paid in the year. How do I get the ending balance? The beginning balance for that year, subtract out the principal paid during that year, and that's going to give me the ending balance. And then where does that ending balance go? It becomes the beginning balance for the next year, and we just keep doing this. Now, you can do this, I know you can't, but here's how the most common question that I will ask on an exam. I will tell you that you're going to borrow so much to buy a house, and I'll give you the interest rate, and of course it's 360 months. You're going to figure out the amount of the payment, and I'm going to ask you, what is the total interest paid over the life of the loan? And your first thought is, that bastard is going to make me create a table for 360 months and then add all that interest together. You could do that if you had until now, till the end of eternity to do that. But here's the easier way. Remember, we said that each payment represents interest and principal. And so if I multiply the amount of the payment by the number of payments, that is the total amount of interest and principal that I pay over the term. Do I know the amount of principal? Yeah, it's the amount that I borrowed, right? And so all I've got to do is take the payment times the number of payments and then subtract out the amount that I borrow, and that gives me the total amount of interest that I pay over the life of the loan. Would you like me to say that again? If you want to find out how much interest that you pay over the life of the loan, all you have to do is take the payment times the number of payments. That's going to give you the total amount of money that you paid. Now, we said that represents both interest and principal. If it's both interest and principal, all I have to do is subtract out the principal, which is the amount that I borrowed. Right? Does that make sense? And so all we would have to do here is take 1285.46 multiplied by 5 equals minus 5,000. Tells me that I spent $1,427.31 in interest. And if we look down here, so do you guys on your slides, do you see where it says down at the bottom 1427.31 as the total for that?
Yes.
Wouldn't it be easier just to do what I told you there, multiply the payment times the number of payments, subtract out the principal, than to try to figure out all the interest and add them together? Absolutely. Any questions?
I'm still confused that I figured out the 450 on the first one.
Okay, what's 9% of $5,000?
Okay, gotcha.
Other questions? Okay, see you next time. Bring your questions for exam 1 review.